Close your eyes for a moment and think about this. Every atom in your body, every breath you take, every beat of your heart, all of it was forged in the heart of a star. The calcium in your bones, the iron in your blood, the oxygen filling your lungs, they were not born on Earth. They were created billions of years ago in the fiery furnaces of ancient suns. And when those stars died, scattering their ashes across the cosmos, they carried within them the seeds of you. This is the great truth. You are not separate from the stars. You are their continuation. You are starlight, made flesh. It's easy to forget this in the rhythm of our days, in traffic, in work, in the 1,000 distractions of modern life. But tonight, I want to bring us back to that reality. We're going to follow the stars on their journey, from their dark beginnings in clouds of dust and gas, to their brilliant lives of shining light, to their spectacular deaths, and to their quiet legacy. This is not just astronomy, this is our story too. Because when you look up at the night sky, you are looking into your own past. The light of the stars that reaches you tonight began its journey before you were born, before humanity built its cities, before even our species walked the earth. To see the stars is to see history written across the heavens, and to understand their lives is to understand ourselves. But before we begin, let me ask you something. I'd love to know, where in the world are you listening from tonight, and what time is it for you under your sky? Share it in the comments below. I think it's wonderful that we can be here together, scattered across the planet, yet united in this journey through the life of the stars. The journey begins in silence. Imagine a vast, dark cloud of gas and dust floating in space. Cold, heavy, seemingly lifeless. For millions of years it drifts, waiting. But gravity is patient. Slowly it pulls the atoms together. Denser regions form, clumps grow, and knots of matter begin to collapse. Deep in their cores, the pressure builds, and one day, in a sudden flash, a star is born. A new point of light flickers into existence, adding its glow to the tapestry of the cosmos. This is the first chapter of every star's life, and it is the first chapter of ours. You see, every star is a story. Each one has a beginning, a middle, and an end. They are not eternal, though they may live for billions of years. They grow, they change, they die, and in their death they leave behind the building blocks of new stars, new planets, and new life. The universe is a grand recycling of light, and we are part of that cycle. And remember this, every star's story is also our story. As we follow their lives tonight, let yourself drift. You don't need to hold every detail. Let the rhythm of the story carry you. Because the life of stars is not just about physics and fusion, it is about perspective. It is about remembering that you are connected to the cosmos, that your moments are woven into the same fabric that births galaxies. Over the next hour, we'll see stars being born in nebulae, glowing for eons, swelling into giants, and dying in brilliance. We'll watch them scatter their ashes across the universe, seeding the next generation of suns, and at the end, we will return to where we began, to you, to me, to all of us, stardust, walking and breathing, dreaming beneath the stars. So, settle in, breathe deeply. This is a journey for the ear and the imagination. A slow, gentle unfolding of a story that began billions of years ago, and that continues inside you at this very moment. The life of stars is the life of the universe itself, and tonight it is your story too. Imagine drifting in the dark between the stars. Out here, far from the warmth of suns, space is cold and still. For millions of years, vast clouds of gas and dust float silently, spanning light years across the galaxy. They appear lifeless, faint shadows against the background of starlight. But within these clouds lies the potential for creation. These are stellar nurseries, the cradles of stars. And though they seem motionless to us, within them gravity is at work. It is patient, relentless, forever drawing matter together. Tiny ripples of density form, clumps of gas slowly gather. Over hundreds of thousands of years, these knots grow denser, heavier, and hotter. If you could watch it unfold in time-lapse, you would see threads of gas collapsing, swirling, spiraling inward. And in the deepest cores, where the pressure becomes immense, something extraordinary happens. The atoms, mostly hydrogen, are pushed so tightly together that their very nature changes. Their nuclei fuse, releasing energy. Light bursts into existence where once there was only darkness. A star is born. This moment is as close to magic as nature allows. From silence and cold comes brilliance and warmth. From formless gas comes structure and radiance. The universe, once again, writes a new story of light. And remember this, every star's birth is the beginning of another chapter in our own story. For without those stars, there would be no worlds, no oceans, no life, no us. As newborn stars ignite, they are not alone. Stellar nurseries often give birth to thousands of stars at once. The Orion Nebula, for example, glows in our night sky as a cloud of gas and dust illuminated by young suns, only a few million years old, infants by cosmic standards. Their light pushes outward, sculpting the surrounding gas into delicate filaments, hollowing cavities where future generations of stars may form. It is a cosmic cycle, endlessly repeated. Clouds collapse, stars ignite, they shine, and they shape the galaxies they live in. And if you ever feel small beneath the night sky, remember, you're looking at the same process that created the matter inside you. That connection cannot be broken. Every star is a continuation of the universe's story, and every birth is a reminder that creation is never finished. Picture it now, a star just kindling, glowing faintly, its fusion engines sparking for the first time. Around it, a disk of leftover gas swirls, out of which planets will one day form. Perhaps those planets will be barren, or perhaps, in time, they will give rise to oceans, forests, and creatures that wonder about their origins. It is astonishing to realize that every world, every living being, begins with this same quiet process. The collapse of clouds in the darkness, the first light of a star breaking free. So the next time you see an image of a nebula, a swirl of pink and blue in the vastness of space, know that you are seeing the universe at work, mid-creation. It is as though you are peering into a nursery, watching new lives emerge. And here is a thought to hold on to. When you look up at the stars tonight, some of the light you see has only recently begun its journey, born from suns that ignited long after humanity first walked the earth. Others began shining billions of years before us and will continue long after we're gone. This mixture of old and new, ancient and newborn, is what gives the night sky its richness. It is not a static canvas, but a living, changing, evolving tapestry. Every birth of a star is also the birth of new possibilities. As we continue our journey, we will see how those possibilities unfold, how stars live out their long lives, how they create the very elements that build us, and how they eventually return their gifts to the cosmos. But never forget, each shining point of light began in silence, in the cold emptiness, in a cloud that seemed lifeless. And from that emptiness came everything. Every star's story is also our story. There is a moment in the life of a star when everything changes. For millions of years, a protostar gathers mass, collapsing under its own gravity. It glows faintly from the heat of compression, but its heart remains dark. Then, in a single instant, the balance tips. Deep in the core, the temperature climbs to millions of degrees. Hydrogen nuclei collide with such force that they fuse into helium. In that fusion, a new kind of fire is lit, one that does not consume, but endures. Light floods outward. A star once hidden in its cloud now blazes into brilliance. This is the first light. It is difficult to describe what this means on a cosmic scale. For the first time, the newborn star pushes back against gravity's grip. Fusion provides the energy needed to resist collapse, creating a perfect balance between two opposing forces. The star will shine steadily, sometimes for billions of years, as long as this balance holds. In these moments, the universe writes the opening chapter of another story, one that will ripple across time and space. When we look at the night sky, many of the stars we see are in this stable phase, burning hydrogen in their cores. They are the steady candles of the cosmos, pouring energy into their surroundings. Our own sun is one of them, a middle-aged star, burning quietly, neither at its beginning nor at its end. And as we sit beneath its light, we are sustained by it in every way. The warmth you feel on your skin, the breath of air you take into your lungs, the food you eat, All of it is possible only because of the energy released in that silent process of fusion, deep within the heart of a star. And remember this, when a star shines, it is not just light we see, it is a promise that the universe, even in its silence, creates and sustains. The first light does more than illuminate space, it sculpts it. Streams of radiation carve cavities in the surrounding nebulae, shaping tendrils of gas and revealing new layers of beauty. Whole clouds glow, painted in pinks, blues, and golds by the energy of the stars within. Telescopes show us these cosmic cradles glowing like lanterns in the dark, each one holding hundreds or thousands of young suns. And yet, even in their multitude, each star is unique. Its future will be written by its mass. A small star may live for trillions of years, glowing faintly but enduring almost forever. A massive star will blaze fiercely, consuming its fuel in only a few million years before collapsing in violent death. In this way, stars teach us about balance. To shine brighter often means to live shorter. To conserve, to burn slowly, is to endure. Perhaps there is a lesson there for us too. When I stand beneath the stars, I often think of that first light. I imagine the moment when gravity, after millions of years of patient work, gives way to radiance. A silent, invisible process suddenly transformed into brilliance that can cross the universe. And I think of how our own world is cradled in that balance. Earth, bathed in sunlight, is not just a planet orbiting a star. It is the child of a cosmic process that began long before humanity existed. Without that first light, there would be no oceans, no forests, no cities, no voices to tell this story. Every star's story is also our story. And so, when you next see the sun rise, think of it not only as the beginning of a new day, but as a continuation of a journey that began 4.6 billion years ago, when hydrogen first fused into helium at the heart of our star. The sunrise is a daily echo of the first light. Our journey with the stars has only just begun. They will live long lives, each unique, each magnificent, and their fates, whether quiet or violent, will shape everything that follows. So let us follow them further, deeper into their hearts, where fusion forges the elements of the universe, because in those hidden furnaces lies the next chapter of our story, the making of everything we are. Stars, like people, have lifetimes. They are born, they live, and eventually they die. But the span of those lives can vary dramatically, and the path a star follows depends on one simple measure: its mass. A small star may live for trillions of years, longer than the universe itself has existed so far. A medium star like our Sun lives for billions, and the most massive stars, though they blaze with extraordinary brilliance, burn out in only a few million years. It is as if the stars are candles. Some flicker faintly, conserving their wax for eons. Others flare brightly, consuming themselves in a rush of light. The flame may differ, but the story is always the same. A balance between gravity, which seeks to collapse, and fusion, which pushes outward. Our Sun, for example, is halfway through its main sequence, the steady middle years of a star's life. For about 4.6 billion years, it has burned hydrogen into helium, radiating light and heat. For roughly another 5 billion, it will continue to do so, keeping Earth bathed in energy, sustaining life, and anchoring our solar system. But no star can burn forever. When a star exhausts the hydrogen in its core, the balance begins to shift. Gravity starts to win, the star contracts, its core grows hotter, and new layers of fusion ignite. For smaller stars, this means a long, slow fading. For larger stars, it is the beginning of transformation into giants, into novas, into supernovas. And remember this, the destiny of a star is written in its mass. That one measure determines everything, how it lives, how it dies, and what it leaves behind. The smallest stars, known as red dwarfs, are dim and cool. They burn so slowly that not one has yet reached the end of its life. The universe is not old enough for us to have seen it happen. These stars will glow for trillions of years, outlasting galaxies, outlasting perhaps even the memory of our species. Stars like our Sun tell a different tale. When their hydrogen is depleted, they expand into red giants, swallowing nearby planets, shedding their outer layers and leaving behind a small, dense core. A white dwarf, glowing faintly as it cools into darkness. And then there are the giants, the most massive of all. Their lives are short and furious. They burn hydrogen, then helium, then heavier elements, layer upon layer, until they reach iron. At that point, no more energy can be gained. The balance collapses, and in seconds the star tears itself apart in a supernova, one of the most powerful explosions in the universe. In that violent death, new elements are hurled into space: gold, uranium, iodine, the rarest materials of all. These will drift through galaxies, gather into new clouds, and seed the birth of new stars and planets. Every star's story is also our story. Because when you hold a piece of gold, or when you breathe oxygen, or when you feel iron coursing through your blood, you are holding the legacy of a star's life and death. The cycles of the cosmos flow through you. There is something humbling in this perspective. Stars, from the faintest red dwarfs to the brightest supergiants, follow paths set by the laws of physics. And yet, those same paths create the conditions for life, for thought, for love. Look at the night sky, and you see not only points of light, but stages of existence. Some stars are just beginning, others are steady in their middle years, and some are already nearing their end, destined soon to flare and fade. It is a reminder that we too are travellers through time, living within our own cycles, our own arcs of beginning, middle, and end. The life cycle of stars is not just a cosmic story, it is a mirror. And so we continue, following them deeper into their cores, where fusion builds the elements of the universe itself, where the real alchemy takes place. For within the hearts of stars, the raw materials of life are being forged at this very moment. If you could travel into the heart of a star, you would enter a world unlike anything on Earth. Temperatures soar to millions of degrees. Pressures crush with unimaginable force. Atoms, stripped of their electrons, move so quickly and collide so violently that they fuse into new forms of matter. This is the alchemy of the cosmos. At first, hydrogen is the fuel. 4 protons merge to form helium, releasing energy in the process. That energy streams outward as light and heat, pushing against gravity and giving the star its steady glow. For billions of years, this simple cycle, hydrogen into helium, sustains a star's life. But stars do not stop there. As the hydrogen in the core becomes depleted, the temperature rises and heavier elements begin to fuse. Helium becomes carbon. Carbon fuses into oxygen. Oxygen into neon, silicon, sulfur. And so the ladder continues, each rung demanding more heat, more pressure, until iron appears. And here lies the limit. Iron cannot release energy through fusion. When a star fills its heart with iron, its life hangs in the balance. Gravity will soon claim its victory and the star's fate will be sealed. And yet, in the meantime, the process is astonishing. The very atoms that make up life on Earth are being forged inside these stellar furnaces. The calcium in your teeth, the oxygen in every breath, the iron in your blood, all of it was created in the heart of a star. And remember this, when you look in the mirror, you're looking at matter once cooked in the heart of suns. It is extraordinary to think that something so violent, so extreme, is also so necessary for life. Without fusion, the universe would be dark, filled only with hydrogen and helium. There would be no Earth, no oceans, no trees, no creatures to wonder about the stars. Fusion is the engine not only of stars, but of creation itself. Imagine standing at the edge of this stellar heart, watching the dance of particles. Protons collide, bind, and release energy. Neutrons and electrons swirl in the chaos. The forces of nature, gravity, electromagnetism, the strong nuclear force, all converge in this one place, producing the light that travels across space to touch your skin. And though you cannot see it directly, you live in its glow every moment. The warmth of sunlight, the food you eat, the air you breathe, all are sustained by that invisible process, hidden deep in the sun's core where atoms are being reshaped. It is tempting to think of stars as distant, untouchable objects, but their hearts beat inside us. Every cell of your body carries the heritage of stellar fusion. You are, in a very real sense, a fragment of a star's memory. Every star's story is also our story. In this way, stars are more than cosmic objects. They are storytellers. Their light tells us what has been, what is, and what will come. By studying the light that leaves their cores, split into rainbows by our instruments, we can read the signatures of the elements within them. We can know their ages, their temperatures, their compositions. It is as though the stars are speaking, and we are only now learning to listen. And so, as we gaze deeper into the universe, we see that the hearts of stars are not just engines, but archives. They record the unfolding history of creation, written in light, carried across billions of years to reach us. When you step outside and look at the stars tonight, take a moment to think of what lies at their centres. Not just light, but the making of everything you know. The heart of a star beats inside you, and inside everything you love. No star can burn forever. Even the most patient furnaces in the universe must one day exhaust their fuel, and when that happens, the balance that held them steady for so long begins to shift. For stars like our Sun, the end comes gradually, not in sudden violence, but in a long, graceful fading. When the hydrogen in the core is depleted, fusion slows. Gravity begins to take control once more, pulling the core inward. But as the core contracts, the layers above it heat up. New shells of fusion ignite, burning hydrogen around the shrinking heart. And so the star responds, it swells outward. The star becomes a red giant. Imagine our Sun in this future, 5 billion years from now. Its light will grow dimmer and redder, while its outer layers balloon outward, engulfing the inner planets. Mercury and Venus will be consumed, their orbits erased in fire. Even Earth may not survive, as the swelling sun scorches its surface and strips away its oceans and atmosphere. But even in destruction, beauty appears. The outer layers of the dying star drift into space, forming great glowing shells of gas. These planetary nebulae, as astronomers call them, are among the most delicate and beautiful sights in the universe. Rings, bubbles, and wisps of coloured light, sculpted by the gentle breath of a fading star. And at the centre of this glowing cocoon lies what remains, a white dwarf. A white dwarf is no larger than Earth, yet it contains the mass of a star. It is impossibly dense. A teaspoon of its matter would weigh tons. No new fusion burns within it. Instead, it glows faintly, powered only by the leftover heat of its long past. Over billions of years it will cool, fading slowly into darkness, a silent ember adrift in space. This is the fate of our Sun. And remember this, every star's ending is also a beginning. For in casting off its outer layers, the red giant enriches its surroundings with the elements it forged during its lifetime. Carbon, oxygen, nitrogen, the building blocks of life, are released into space, ready to seed the birth of new stars and new worlds. So even in death, a star gives. Its life continues in other forms, scattered across the cosmos, waiting to rise again. When you look at images of planetary nebulae, delicate rings of turquoise, pink and violet, you are seeing the last breath of stars like our Sun. Their beauty is fleeting, lasting only tens of thousands of years, a heartbeat in cosmic time. And yet, in that brief moment, they remind us of a truth we sometimes forget. Endings can also be luminous. It is humbling to think that the atoms in your body may once have passed through such a final act. The carbon that shapes your cells, the oxygen that fills your lungs, could have been cast off in the death throes of a long-forgotten star. You carry within you the memory of countless stellar deaths. Every star's story is also our story. So as we look at the quiet fading of small and medium stars, let us remember that life too finds meaning in its impermanence. It is because stars die that new stars are born. It is because time moves forward that new possibilities arise. Our Sun, in its distant future, will become one of these quiet remnants, a white dwarf, shining faintly among the stars. By then, Earth will be gone, and humanity's chapter may have ended or transformed beyond recognition. And yet, the elements of our world will not vanish. They will join the cosmos again to be carried into the next generation of suns. The death of stars is not the end of the story. It is a handover, one chapter closing, another beginning. And as we continue, we will see what happens when massive stars reach their end, when their deaths are not gentle but explosive, reshaping galaxies with their brilliance. If the death of small and medium stars is quiet, graceful and slow, the death of massive stars is the very opposite. It is violent, sudden and spectacular, an ending so powerful that it shapes the course of galaxies. These are the giants of the cosmos, 10, 20, even 100 times the mass of our Sun. Their lives are short, only a few million years, because they burn with extraordinary intensity. They live fast and they die young. Deep in their hearts, fusion builds heavier and heavier elements. Hydrogen becomes helium, helium becomes carbon, carbon becomes oxygen, and the chain continues. But when iron forms, the star reaches its limit. Fusion can no longer release energy, the core becomes unstable, and then, in the span of a heartbeat, gravity wins. The star collapses inward with unimaginable force. The core shrinks in a fraction of a second, heating to billions of degrees. Outer layers crash down and rebound in a titanic explosion. This is a supernova, one of the most powerful events in the universe. For a brief moment, a single star can outshine an entire galaxy. The energy released is almost beyond comprehension, and in that instant, new elements are forged. Gold, uranium, and other heavy metals, created only in this final act of destruction. And remember this: every piece of gold on Earth, every atom heavier than iron, was born in the death of massive stars. Your wedding ring, the electronics you use, even parts of your own body carry within them the memory of a supernova. The debris of the explosion expands outward, forming colourful remnants, clouds of gas and dust that spread across space, glowing in X-rays and radio waves. These remnants enrich their surroundings, seeding new stars, new worlds, and new possibilities. But the story does not end there, for in the heart of the explosion lies what remains of the star's core. If the star was massive, but not too massive, that core becomes a neutron star. A neutron star is one of the strangest objects in the universe. Imagine compressing the mass of our Sun into a sphere only 20 kilometers across. Matter is crushed so tightly that protons and electrons combine to form neutrons. A teaspoon of this material would weigh billions of tons. Neutron stars spin rapidly, sometimes hundreds of times per second, beaming radiation into space like a cosmic lighthouse. These are pulsars, flashing with astonishing regularity, ticking like the universe's most extreme clocks. And if the star is even more massive still, the collapse does not stop. Gravity pulls everything inward until not even light can escape. A black hole is born. Black holes are the most extreme objects in existence. They are regions where space-time itself is bent so steeply that escape becomes impossible. To approach the event horizon, the boundary of no return, is to witness time itself slow, almost to stillness. For an outside observer, anything falling in appears frozen forever at the edge, but from within the fall is swift, inevitable, and final. And yet even black holes are not purely destructive. They shape galaxies, drive the growth of stars, and may even play a role in the evolution of life. They are not merely cosmic graves, they are also engines of creation, influencing the universe on the grandest scales. Every star's story is also our story. When you look at the night sky, remember that the heavy elements of your world, the rarest treasures of our planet, were born in these cataclysms. The violence of supernovae, the silence of neutron stars, the mystery of black holes, all of it flows into you. There is a strange comfort in this. From destruction comes creation, from endings, new beginnings. So as we leave behind the explosive deaths of massive stars, we turn to what they leave behind, their legacy. For even in death, stars continue to shape the universe. Their ashes, their remnants, their memories, all scattered into the cosmos, waiting to rise again. The death of a star is never the end. Even when a star fades into a white dwarf, or tears itself apart in a supernova, it leaves behind something far greater than itself. Its ashes are scattered across space, carried on stellar winds, drifting through galaxies, and in those ashes lie the elements of creation. This is the legacy of stars. Carbon, oxygen, silicon, iron, gold. These are not produced on Earth. They are not the inventions of planets. They are the gifts of stars made in their cores and released in their deaths. Every molecule of water, every crystal of rock, every breath of air owes its existence to those distant furnaces. And remember this: when you hold a stone in your hand, or drink a glass of water, or look into the eyes of someone you love, you are holding the legacy of stars. The universe is a recycler. The matter cast off by dying stars drifts through galaxies, gathering into new clouds of gas and dust. Gravity once again pulls those clouds together, and in time, new stars are born. Around them, disks of debris swirl, forming planets, some rocky, some gaseous, some destined to remain barren, and some, perhaps, capable of supporting life. Our own solar system was born from such a cycle. About 4.6 billion years ago, a cloud of gas and dust collapsed, likely triggered by the shockwave of a nearby supernova. In that cloud were the ashes of countless stars that had lived and died before. From their remnants came the sun, the planets, the Earth, and eventually us. Every star's story is also our story. When you walk outside and feel the solidity of the ground beneath your feet, you are standing on ancient stardust. When you breathe in, the oxygen filling your lungs is a gift from stars that lived billions of years ago. The calcium in your bones was forged in stellar furnaces. You are, in the most literal sense, a child of the stars, and it is not just us. All life shares this legacy. The trees, the oceans, the animals, every living thing is built from the element stars once created. The legacy of stars is written into the DNA of every cell, a cosmic signature carried forward through time. The beauty of this truth is that it transforms how we see the universe. We are not separate observers, looking out at a distant sky. We are participants. We belong to this story, and yet the legacy of stars goes beyond matter. It is also energy, light, and order. The structure of galaxies, the cycles of birth and death, the chemistry of life, all flow from the lives of stars. Their influence extends across billions of years and trillions of kilometers, shaping not only what is, but what can be. Think of it this way. The atoms of your body once travelled across the galaxy. They may have been part of a star that shone brightly in a long-vanished cluster, or part of a planet that circled that star. They may have been scattered by a supernova, drifting for eons before coming to rest here, in you. And they will not stop here. Long after you're gone, those atoms will continue their journey. They may become part of another world, another star, another being. The legacy of stars is eternal, and you are a part of it. There is a profound comfort in knowing this. We are not fleeting shadows in a vast, indifferent cosmos. We are the universe made conscious, a way for stardust to look back at itself and wonder. So, as we move forward, let us carry this truth with us. We are the legacy of stars. Their lives, their deaths, their gifts, all are within us. And as we turn now to the stars beyond, to the exotic and extraordinary forms that challenge our imagination, we do so with this understanding. The universe is not just out there, it is in here. Every star's story is also our story. By now, we've traced the familiar path of stars, from their birth in nebulae to their shining middle years to their deaths and legacies. But not all stars fit neatly into that cycle. Some are stranger, rarer, and more extreme. These are the stars beyond, the ones that remind us that the universe is always capable of surprise. Consider the neutron star. We've already glimpsed it in the aftermath of supernovae, a remnant no larger than a city, yet so dense that a teaspoon of its matter would outweigh mountains. Some of these stars spin rapidly, hundreds of times each second, sweeping beams of radiation through space like cosmic lighthouses. We call them pulsars. Imagine standing on the surface of one, if such a thing were possible. Gravity would crush you instantly, billions of times stronger than Earth's. The magnetic fields would tear apart atoms. Yet from afar they are steady, reliable beacons. They tick like clocks, their pulses so regular that astronomers use them to measure time itself. And remember this, even in their extremes, stars continue to mark the passage of time for the universe. Then there are magnetars, even stranger cousins of neutron stars. Their magnetic fields are trillions of times stronger than Earth's, so intense that they can twist space itself and shatter atoms. Occasionally, they release bursts of energy so powerful they can outshine all the stars in a galaxy for a fraction of a second. These are some of the most violent objects ever observed, and yet they are born from the same processes that shape ordinary stars. Stars also come in pairs, and even in families. Binary stars are common. Two suns orbiting one another, locked in a gravitational dance. Some feed off each other, matter flowing from one star to another, creating bursts of light as they collide and interact. Entire solar systems can orbit such pairs, their skies filled not with one sun but two. Imagine standing on such a world, watching twin dawns rise one after another. And then there are the most luminous stars of all, quasars. Though technically powered by supermassive black holes at the centres of galaxies, their brilliance is tied to the matter they consume. As stars and gas fall inward, they heat to incredible temperatures, producing beams of light that can be seen across billions of light years. To look at a quasar is to look back to the dawn of the universe, when galaxies were young and the cosmos was ablaze with creation. The stars beyond challenge our imagination because they remind us that the universe is not limited to what is familiar. It holds forms of matter and energy that seem almost impossible. Neutron stars that spin like tops, magnetars that twist reality, binary stars that weave dances of destruction and creation, quasars that shine like cosmic lanterns across the void. Every star's story is also our story, because even these exotic objects are part of the same cycle. Neutron stars are born from death. Quasars reveal the growth of galaxies. Binary stars enrich the cosmos with their interactions. They are all threads in the same great tapestry, reminding us that creation comes in many forms, and what they leave behind is not just matter, but knowledge. By studying them, we learn about the laws of nature at their limits, how gravity bends, how particles behave, how space-time itself is shaped. These stars are laboratories that no human could ever build, yet they teach us truths about the universe with astonishing clarity. When you look at the stars tonight, know that some of them may be paired, some may be pulsing, some may be hiding secrets we have not yet imagined. The cosmos is not finished surprising us, and as we leave these extraordinary forms behind, we return to a more familiar truth, that all stars, however strange, share a common destiny. They live, they change, they die, and they leave behind their gifts, and among those gifts is us. The life of stars is the life of the universe itself, and it is our life too. Stars are not solitary creatures. Though some wander alone, most are born in groups, families of hundreds, thousands, even millions. They emerge together from the same clouds of gas and dust, bound at first by gravity, and linked forever by their shared origins. These groups are called star clusters. They are the nurseries and the communities of the cosmos, places where stars are born side by side, their light blending to illuminate the surrounding space. Open clusters are the youngest of these families. They are loose gatherings of stars, only tens or hundreds of millions of years old. One of the most famous is the Pleiades, sometimes called the Seven Sisters, visible to the naked eye as a delicate sprinkling of light in the constellation Taurus. Look at them through a telescope, and you see dozens of stars, siblings, shining together against the darkness. Over time, open clusters disperse. Gravity from the galaxy pulls them apart, scattering their members across the spiral arms. The stars drift into the wider cosmos, but they never forget where they came from. Their chemical fingerprints remain the same, a clue to astronomers that they were once born together. Globular clusters are different. They are ancient, some more than 12 billion years old, nearly as old as the universe itself. Containing hundreds of thousands of stars packed tightly into a sphere, they hang around galaxies like glowing lanterns. When you see them through a telescope, they appear as swarms of light, countless stars crowding together, like grains of sand scattered in a bowl. And remember this, in every cluster, stars share a beginning. They are bound not only by gravity, but by story. There is a lesson for us in this. We too are born in families, in communities. We too are shaped by the environments in which we begin. And though we may drift, carried away by time and change, the memory of where we came from remains within us. Clusters are also laboratories for understanding the lives of stars. Because they are born together, they share an age and a composition. Astronomers can compare them, seeing how stars of different masses evolve side by side. It is as though the universe has written its experiments in the sky, allowing us to read the results across billions of years. Imagine standing on a world within a globular cluster. The night sky would be ablaze, filled with thousands of stars shining brighter and closer than anything we know. Darkness would never be complete. Every horizon would glow with starlight. What would it feel like to live under such a sky? Would you feel overwhelmed or comforted? Would you feel smaller or more connected? Every star's story is also our story. And just as families of stars shape their galaxies, so too do families of people shape their world. The parallels are striking. The stars remind us that existence is not solitary. It is shared, interwoven, collective. As clusters age, they evolve. Some dissolve into the galaxy, others endure, tight-knit and resilient, glowing for billions of years. and through them all runs a truth. Stars are rarely alone, and even when they seem solitary, their histories are shared. So when you next look at the Pleiades, or at a picture of a globular cluster, remember that you are seeing families of stars, born together, shining together, and sometimes dying together. The universe is a community. It is not just a scattering of isolated lights, but a web of relationships. And in that web, stars, like us, find their beginnings, their companions, and their destinies. Every star's story is also our story. And now, as we leave the families of stars, we turn to their children, the planets. For around every star, worlds are born, sculpted from the debris left behind. And some of those worlds in time will give rise to life. When a star is born, it rarely emerges alone. Around it, a swirling disk of gas and dust begins to take shape, flattened by rotation, warmed by the star's first light. This disk is the birthplace of planets, moons, and all the worlds that may one day circle that star. In the beginning, the disk is chaotic. Tiny grains of dust collide, stick and grow. Pebbles become boulders, boulders become mountains, and mountains become worlds. Over millions of years, these clumps clear paths through the disk, sweeping up material as they orbit. Eventually, they settle into planets, rocky worlds close to the star, and giant gaseous planets farther out, where the cold allows lighter elements to remain. Our own solar system tells this story. The Earth, the rocky planets, the gas giants, even the icy bodies at the edge of the Kuiper Belt, all began as dust grains circling a newborn sun. Out of disorder came order. Out of dust came worlds. And remember this, every planet is a child of a star. Planets are not mere byproducts. They're essential to the story of stars. Their orbits shape the debris left behind. Their gravity sculpts disks into rings and gaps, and their presence influences the evolution of the system. In turn, the star sustains them, bathing them in light, holding them in orbit, fueling their climates and cycles. But not all planetary systems are like ours. Astronomers have now discovered thousands of exoplanets, worlds orbiting stars far beyond the Sun. Some hug their stars tightly, completing an orbit in days. Others wander far away, tracing paths that take hundreds of years. Some are larger than Jupiter, orbiting closer than Mercury. Others are rocky, Earth-like, resting in the habitable zones where liquid water could exist. There are planets of fire and planets of ice, worlds that rain glass, and worlds that may hold oceans beneath frozen crusts. There are gas giants orbiting binary suns, where twin stars rise and set together. And somewhere, perhaps, there are planets where life has begun, just as it did here. Every star's story is also our story. Because when we look for planets, what we are really looking for is ourselves, reflections of Earth, places where the chemistry of life may have taken hold. The discovery of exoplanets is not just an exploration of other systems, but a search for companions in the cosmos. Think of this. For most of human history, we believed Earth was unique, the only world in the heavens. Now we know that planets are common. Almost every star may host them. The universe is not empty, but filled with countless worlds. The night sky is a map, each point of light a sun, each sun perhaps encircled by planets, some barren, some fertile, some waiting. If you stood on one of those worlds, what would you see? Perhaps a red sun filling the sky, or two suns casting twin shadows. Perhaps rings arcing overhead, or skies thick with clouds of methane. Perhaps you would look up at night and wonder, just as we do, if you were alone. And yet, in all this variety, one truth remains. Planets and stars are bound together. Their stories cannot be told apart. The lives of planets depend on their suns, and the legacy of stars is carried forward in the worlds they create. So when you look at Earth, do not see it only as a home. See it as a child of the sun, born from dust, shaped by light, held in orbit by the same forces that govern the cosmos. Every star's story is also our story. As we continue, we will discover that some stars do not shine steadily. They flicker, pulse, and vary, beating with cosmic rhythms. These stars, variable and restless, have their own part to play in our understanding of the universe. Not all stars shine with steady light. Some pulse, flicker, or flare, their brightness changing over hours, days, or years. These are the variable stars. suns with rhythms of their own, beating like cosmic hearts across the darkness. One of the most famous types is the Cepheid variable. These stars expand and contract in regular cycles, growing brighter and dimmer in a steady rhythm. Their pulses can last days or weeks, and the pattern is so precise that astronomers use them as cosmic yardsticks. By measuring their brightness, we can gauge their distance, allowing us to map the scale of galaxies far beyond our own. It is extraordinary to think that the heartbeat of a star can measure the size of the universe. Other variable stars are more dramatic. Some are binary systems where one star passes in front of the other, causing the light to dip in a regular eclipse. Others flare unpredictably, releasing bursts of energy that ripple across space. Some explode in novas, their light surging for weeks before fading again into quiet. And remember this: even in their flickering, stars keep time for the universe. For astronomers, variable stars are not just curiosities, they are tools, guiding us through the cosmos. Cepheids revealed the true scale of the Milky Way, and then showed us that our galaxy is just one of many. They helped prove that the universe is expanding, that galaxies are racing away from one another, carried by the stretching of space-time itself. Think of what that means. A single star pulsing in the darkness holds within it the key to understanding the fate of the cosmos. Every star's story is also our story, and there is something profoundly human about variable stars. They remind us that life too is not steady. We have seasons of brightness and seasons of shadow, moments of expansion and contraction, times when we flare with energy and times when we fade. Our lives are not constant, but rhythmic. If you stood on a world circling a variable star, the sky would change in ways we can barely imagine. The sun might swell and dim across the span of weeks, altering the climate, shifting the shadows, painting the sky with light that comes and goes. Life under such a sun would adapt to cycles stranger than any on Earth. And yet, those cycles would still be reliable. They would still mark the passing of time, the rhythm of existence. Just as the beating of your heart marks your life, the pulses of these stars mark theirs. Variable stars remind us that stability is not the only form of order. Even change itself can be a kind of pattern, a rhythm that carries meaning. When you look at the stars tonight, imagine that some of them are flickering, brightening and dimming, carrying their rhythms across space. And know that, by watching carefully, we can learn from them not only about their own lives, but about the vastness of the universe itself. Every flicker, every pulse, every rhythm is a message, carried in light, waiting for us to listen. And as we leave these stars with their strange, beautiful rhythms, we turn our gaze closer to home. For one star in particular matters to us more than any other. It is steady for now, but its future is already written. The story of our sun, and the fate of the world it sustains, is the next chapter. Of all the stars in the universe, none matters to us more than the sun. It is our anchor, our source of warmth and light, the steady presence that sustains every heartbeat and every breath on Earth. For billions of years it has shone quietly in the sky, a constant companion to life. But even the sun is not eternal. Its story, like all stars, has a beginning, a middle, and an end. At this moment, our sun is in its middle years, about 4.6 billion years old, with roughly the same span of time still ahead before its life changes forever. Each second, it fuses 600 million tons of hydrogen into helium, releasing energy that streams across space, illuminating Earth. That energy fuels the winds, the weather, the growth of plants, and the chemistry of life. But one day, this balance will shift. The hydrogen in the sun's core will run low. Gravity will press inward, the core will contract and heat, and hydrogen will begin to burn in the surrounding shell. The outer layers of the sun will expand, and our familiar star will transform into a red giant. Imagine the sky of that distant future. The sun will swell until it fills much of the horizon, its light red and dim, its heat fierce and overwhelming. Mercury and Venus will be consumed. Earth's oceans will boil away, its surface scorched into lifeless rock. The blue and green world we know will vanish beneath fire. And yet, even in destruction, beauty will appear. The sun will cast off its outer layers into space, creating a planetary nebula, a glowing shell of gas, delicate and colourful, expanding outward into the galaxy. For a short time, the sky will be filled with ethereal rings of light, the final breath of our star. What remains will be a white dwarf, no larger than Earth, but unimaginably dense. It will glow faintly, the dying ember of a once mighty sun. For billions of years it will slowly cool, fading into darkness. One day it will become a black dwarf, cold, dark, and silent, a remnant adrift in space. And remember this: the death of the sun will not be the end of its legacy. The elements it releases, carbon, oxygen, nitrogen, will drift through the galaxy, joining the cycle of creation. New stars will be born, and new worlds may rise, carrying within them the memory of our sun. Every star's story is also our story. It is natural to feel sadness at this vision of the sun's end. But there is comfort too. The fact that stars die is the reason we exist. Without their endings, there would be no elements, no planets, no life. The death of the sun will be part of the same cycle that gave rise to us. Think of it this way: the sunlight warming your skin today is part of a process that has been going on for billions of years and that will continue long after us. The sun does not burn for eternity, but it burns long enough to make life possible, long enough for us to be here, to know it, to tell its story. When you look at the sun tomorrow, do not see only the bright disk in the sky. See the heart of a star halfway through its journey, still giving everything it has. And remember that you are living in the middle of its story, in a brief golden moment when it sustains a world full of life. The fate of the sun is already written, but so is its legacy. And that legacy will echo across the galaxy, carried by the atoms it leaves behind. And so, as we leave the story of our sun, we widen our view once more. For the sun is not alone. It is one of billions of stars that make up our galaxy, a vast city of light stretching across the sky. The story of stars is also the story of galaxies, and that is where our journey takes us next. If stars are lives, then galaxies are the great cities in which those lives unfold. Each galaxy contains billions, sometimes trillions of stars, bound together by gravity into sweeping structures that span hundreds of thousands of light years. They are islands of light adrift in the vast ocean of the universe. Our own galaxy, the Milky Way, is such a city. It is a barred spiral, its arms sweeping outward in great arcs of starlight, dust, and gas. When you look up at the night sky and see that faint band of light stretching across the darkness, you're looking along one of its arms, peering through the crowded streets of our stellar city. Galaxies come in many forms. Spiral galaxies, like the Milky Way, are graceful pinwheels of light, their arms alive with star formation. Elliptical galaxies are older, more rounded, filled with ancient stars that burn dimly but endure. Irregular galaxies defy order altogether, their shapes twisted by collisions and encounters, cosmic cities reshaped by the tides of gravity. And remember this: galaxies are not static. They're alive with motion. Stars orbit their centers, gas clouds collapse into new suns, and galaxies themselves drift, collide, and merge. Our Milky Way is not alone. It is part of a local group of galaxies, including the Andromeda Galaxy, which is on a slow collision course with us. In about 4 billion years, the two will meet, their stars sweeping past one another in a gravitational dance. Worlds will be carried into new orbits, and the two galaxies will eventually merge into a single, larger city of stars. From our perspective, the night sky will be transformed. Andromeda will grow brighter and larger until it dominates the heavens, filling the view with spirals of light. Imagine standing on Earth, or whatever world exists then, and watching another galaxy rise, filling the horizon, a reminder that even the greatest of cosmic cities are destined to change. Every star's story is also our story. Because galaxies are not just backdrops. They are the environments that shape the lives of stars and ultimately the possibility of life itself. Their structure determines where stars are born, how they evolve, and how matter circulates through the universe. Think of the spiral arms of the Milky Way. They are regions of active star formation, glowing with nebulae and young suns. The space between the arms is quieter, filled with older stars, the suburbs of our galaxy. At the centre lies a supermassive black hole, around which everything orbits, a gravitational anchor for our stellar city. And yet, even amid this vastness, galaxies are fragile. Collisions reshape them, stripping away stars and gas. Tides of gravity sculpt them into new forms. Over billions of years, their light fades as star formation slows and they grow old. If you look at the Hubble Deep Field, an image taken by pointing a telescope at a seemingly empty patch of sky, you see thousands of galaxies, each a city of stars stretching back across billions of years. Some are young and bright, others ancient and fading. Together, they form the great architecture of the universe. And when you see them, remember, you're not just looking at distant lights. You're looking at the homes of countless stars, countless worlds, and perhaps countless forms of life. Every star, every galaxy, every cluster is part of a cosmic web, a tapestry that binds the universe together. And within that web we are a single thread, a part of a story that stretches across billions of light years. So when you stand beneath the stars and see the faint glow of the Milky Way, know that you are standing inside a city of stars, one among billions drifting through the cosmos. Every star's story is also our story, and as we leave the galaxies, we turn our gaze backward in time, to the very first stars. For to understand where we are, we must understand where it all began. To truly understand the life of stars, we must journey back to the beginning, to a time before galaxies, before planets, before even the first atoms had found their places. The universe was young then, only a few 100 million years old, and it was dark. This era is called the Cosmic Dark Ages. After the Big Bang, the universe expanded and cooled. Atoms of hydrogen and helium formed, but there were no stars yet to shine. Space was filled with invisible gas, waiting. And then, slowly, gravity began its work. Small clumps of matter drew together, collapsing into the first dense knots. Temperatures rose, and fusion ignited. For the first time, light pierced the darkness. The first stars were born. These stars, called population 3 stars, were unlike any we see today. They contained only hydrogen and helium, the simplest elements. Without heavier elements to cool their gas, they grew enormous, hundreds of times more massive than the Sun. They lived fast, burning brightly and fiercely, and died young in spectacular explosions. And remember this, the first stars were the architects of everything that came after. When they died, they scattered the first heavy elements into space: carbon, oxygen, iron. They seeded the cosmos with the raw materials needed for planets, for chemistry, for life. Without them, the universe would still be filled only with hydrogen and helium. Without them, we would not exist. It is strange to think that we cannot see these stars directly. They lived and died so long ago that no trace of them remains, but their fingerprints are everywhere, in the elements that make up your body, in the dust that formed the Earth, in the chemistry of life itself. Every star's story is also our story, and the story of the first stars is the story of beginnings. They also changed the universe in another profound way. Their light reionized the cosmos, stripping electrons from atoms and making the universe transparent. Before them, space was filled with a fog of neutral hydrogen that blocked light. After them, the universe became clear, and galaxies began to shine. In this way, the first stars not only created the building blocks of matter, but also transformed the very nature of space itself. Imagine what it must have been like in those first moments of starlight. The universe that had been dark for hundreds of millions of years suddenly illuminated by the birth of suns. The first dawn, written not in days or seasons, but in the blazing of entire stars. We cannot witness it directly, but telescopes are beginning to glimpse the faint echoes of this time. The light stretched by billions of years of expansion, arriving at Earth as a whisper of what once was. And soon, with new instruments, we may see more clearly how the first stars lived and died. Their lives were brief, but their impact eternal. Every galaxy, every planet, every living thing is descended from their legacy. They were the first storytellers, writing enlightened matter, shaping the cosmos into something that could one day give rise to us. And so, when you look at the stars tonight, know that you are seeing their descendants. The universe is old, but it still carries the memory of its first flames. The first stars were the beginning, but the story does not end there, for just as there were first stars, there will also be last stars. The universe's future stretches ahead for trillions of years, and the stars that will shine in that distant time will be unlike any we know today. That is the next chapter, the last stars, and the fate of light in a universe growing old. If the first stars mark the dawn of light, then the last stars will mark its twilight. The universe, vast and unyielding, has its own time scales, and on those scales, even stars are fleeting. Though they may burn for billions or even trillions of years, there will come a time when the stars themselves fade. Imagine a universe far older than our own, not billions of years old, but trillions. By then, the bright stars we know, the giants, the suns like ours, will all be gone. Only the smallest stars, the red dwarfs, will remain. They burn so slowly that their lives span trillions of years, far longer than the universe has yet existed. These faint stars will carry the cosmos through its twilight, glowing dimly, their light soft and red. Around them, worlds may still orbit, perhaps with life clinging to their warmth. For an unimaginably long time, the universe will be lit by these quiet embers, but even red dwarfs cannot last forever. Eventually, they too will exhaust their fuel. They will fade into white dwarfs, glowing faintly as they cool. Over trillions of years more, those white dwarfs will darken into black dwarfs, stars that no longer shine, cold and silent, hidden against the void. And remember this, the universe's story is not only about beginnings, but endings too. Every star's story is also our story. In this distant future, galaxies will grow quiet. Star formation will slow and stop as the fuel for new stars is used up. The great cities of a light will empty, their streets growing dark. Black holes will dominate, swallowing the remnants of stars, merging, shaping what remains of the cosmos. Time will stretch on, unimaginably. The last flickers of starlight will vanish. The universe will become a place of cold remnants, black dwarfs, neutron stars, and black holes drifting in darkness. And yet, even in this vision of an ending, there is wonder. For the story of the stars is not only about their light, but about their legacy. Long after the last star fades, the elements they created will remain. The atoms of carbon, oxygen, and iron will still exist, scattered across space, part of the eternal fabric of the cosmos. Think of it this way. The atoms of your body may one day drift through such a dark universe, long after the stars are gone. You're part of a chain that began with the first stars and will continue into the age of the last. There is a strange beauty in imagining this far future. The cosmos will not end suddenly, but gradually, quietly. The light will fade, but the memory of it will remain, carried in the elements, in the structure of galaxies, in the laws of nature themselves. When you stand beneath the night sky today, you are seeing the universe in its youth. The stars are plentiful, galaxies bright, the cosmos alive with light, but this will not always be so. The night sky of the far future will be emptier, darker, quieter. And yet, the story of those stars will not be lost. It will be written into everything that came from them, into you, into me, into all that exists. Every star's story is also our story. The first stars lit the darkness. The last stars will carry the light until the very end, and between those two moments lies everything, galaxies, worlds, and the brief, beautiful span of our lives. So as we close this chapter, let us hold on to this truth. We are part of a cosmic story that stretches from the first light to the last. We are stardust, alive in the universe's golden age, walking for a moment beneath skies filled with stars. And now, as we draw near the end of our journey, we return to the heart of it all, what it means for us. For if every star's story is our story, then the life of stars is also the life of humanity. We have walked together through the lives of stars, from their birth in clouds of gas and dust, to their long years of shining light, to their spectacular deaths and quiet legacies. We have seen the first stars that lit the universe, and we have imagined the last stars that will one day flicker in its darkness. And through it all, one truth has remained. Every star's story is also our story, because we are not apart from this tale. We are its continuation. The iron in your blood, the oxygen in your lungs, the calcium in your bones, all of it was created in the hearts of stars that lived and died long before the Earth existed. When you look up at the night sky, you're not just seeing distant lights, you're seeing your own origins written in starlight across the heavens. And remember this, you are living in a remarkable moment. The universe is young, its galaxies bright, its stars plentiful. You exist in a golden age when the night sky's alive with light. Trillions of years from now the stars will fade. But you are here, now, to see them, to wonder, to tell their story. It is easy to feel small beneath the cosmos. The distances are vast, the timescales unimaginable. But in another sense, you are vast. You contain within you the history of billions of years. You are a way for the universe to know itself. When you breathe, when you think, when you wonder about the stars, the cosmos is reflecting on its own existence. Every star's story is also our story. So, as you go about your days, carry this truth with you. You are stardust. Your life is part of the same cycle that births galaxies, worlds, and suns. You're connected to everything you see in the night sky. And I would love to know where you are listening from. Share in the comments where in the world you are and what time it is for you beneath your sky. Together, scattered across this planet, we are united in this story. A community of stardust reflecting on the stars. If you've enjoyed this journey, please consider liking and subscribing. It helps us continue to explore the cosmos together, to tell these stories, and to wonder about the mysteries still waiting. Because this is not the end. The universe holds countless other tales, of black holes, of time itself, of what may lie at the very edge of space. This story of the stars is just one chapter in a much greater book, but tonight let us pause here. Look up at the stars. Let their light remind you of what you are and what you are part of. You are not separate. You are not small. You're a thread in the vast tapestry of the universe, woven from the same fabric as the stars themselves. The life of stars is the life of the cosmos, and it is our life too. And that story, your story, my story, the story of every star is still unfolding.